So we're now in my IntelliJ project for the transform microservices example. This is the server side of your solution. And we're going to take a look at more effective ways of handling errors. So the first thing to do whenever you start thinking about error handling and exception handling and so on is to figure out what exactly are the errors that might occur. So let's go take a look at the main controller. This is the one that receives the request from the client and will then farm it out to the various microservices to do the image transforms. So the apply transforms method, which is, as you can see here, an endpoint method that is going to be implementing the post operation with the apply transforms path. And it takes several parameters. It takes the list of transforms. That's one area where an error could occur. It takes a multi-part file image, which is another place that an error could occur. And let's go take a look first at what we need to do at a kind of a high level to make sure that things are caught quickly and the right kinds of error exceptions are propagated back to the caller. So what you can see here is if when you start forwarding the call from the controller to the main service, the image service, one of the things that could go wrong is we might have corrupted bytes in the image. And if that happens, we're going to end up getting an I/O exception. So if we call get bytes here and there's an I/O exception that occurs, which could occur if the user passed in gobbledygook for the image, then what we're going to do is we're going to catch that I/O exception and we're going to convert it to something called a response status exception. And this is something that Spring knows about. And what it's going to do is it's going to actually convert that exception into an error response back to the client. So it'll come back as a message, and it will say the status will be unprocessable entity, and the reason will be unable to read the image bytes. And that will show back up on the client, as we'll see in just a moment. So that's one kind of problem that could occur. Let's take a look at some other things that can occur. So let's go look at the implementation now of apply transforms. And I'm really going to focus in on the build microservice URL method. This is actually one that we provided to you. And what this method does is it goes and it asks the Eureka Discovery Service, what are the microservices registered with you? And if you recall, what that does is it goes and asks the Discovery Service to get the list of the services and then converts that list into a stream. So we get back a stream of strings that correspond to the microservices that Eureka knows about. And what we're then going to do is we're going to check to see whether the microservices we got back, any of them match the transform that was passed over by the client. So there'll be, for example, there'll be a transform name for the sepia transform. There'll be a transform name for the grayscale transform. There'll be a transform name for the tint transform and so on. And so we just want to make sure, as a sanity check, that what the user has requested as the microservices actually correspond to a microservice that's implemented here. And if it is, then we go ahead and we create a base URL, which converts the transform name and adds in this request path and so on. However, if something goes wrong, what is going to happen here is if there's nothing that matches, then we're going to throw the transform exception and explain that whatever transform name the user asked for is actually not running at all. So that will come back to the client in a very interesting way. Let's go take a look at transform exception. Here's transform exception. This is something I added since the skeletons went out. So this is the exception. As you can see, it's a runtime exception, and it essentially encodes in the exception what happened, what went wrong. For example, the transform microservice is not running. And then what we do is we annotate it using Spring annotations. And this is something you should start being familiar with by now. So we use the response status annotation, and we say the reason why this thing has gone awry is because the item is not found, and the reason is there's no such transform. So that's the information that then gets bundled up into a response and is what gets sent back to the client. So the client will end up getting back essentially a response body that encodes this information. And we'll see what that looks like in just a bit. So if somebody tries to look up a transform name for a microservice that does not exist because the client passed the wrong value in, then we're going to get a transform exception thrown back. But there could be other problems. So let's say, for sake of argument, that the user gave a proper transform name. Then that's going to end up calling into the transform controller. And here's the transform controller. And I made a few little tweaks to it because it's cleaner to do it this new way that we came up with. Here's the transform controller. And you'll see that the transform controller has a single method called apply transform, which takes the name of one transform and then the multi-part file. And once again, there could be problems. At this point, hopefully those problems have been dealt with by the main controller. So by the time we get here, we hope that the multi-part file is correct. We hope that the transform name is correct. However, this is a standalone microservice, so we could use it in some other context where we might not actually have the benefit of the main controller doing that sanity checking for us. So we have to recheck those things. So down here, we're going to check, and we're going to see if the name is blank or the file name is null. And we're going to try to get the bytes from the multi-part file. Once again, if an exception is raised, we're going to throw back a response exception. So we have to duplicate that checking here just because we're not entirely sure the context in which this thing gets called. It'd probably be OK, but we need to double check anyway. So now let's go take a look at the apply transform implementation in the transform service class. And this, again, is the code that you had to write. So I made a few little tweaks here to clean things up a bit. So we now have this thing called the transform map, or the mtransform map. And that maps a string name, which is the name of the transform, like sepia transform or grayscale and whatnot, to a consumer to a buffered image. And you'll see that that type matches all these things down here, like grayscale transform, sepia transform, tint transform. That's the signature of those methods. You can see it takes a buffered image as a parameter and returns nothing. And that's well suited to what a consumer functional interface is. So we have a map of string name to consumer to buffer image, which is going to end up pointing to one of those methods. Here's what the constructor does. The constructor stores the corresponding method reference, treated as a consumer to a buffered image, as the value using the name as the key in the map. Now, again, you could get this wrong. You could put the wrong names in here. So we don't necessarily know that the names are correct, and we don't really know, strictly speaking, whether what is passed in here to apply transform is a valid name either. We hope it is, but we don't know for sure. So we do need to do some more sanity checking. So the first thing in this method, we go ahead and convert the image bytes into a so-called buffered image. And then here's the part that's a little different from what we had before. This is arguably the cleanest way of handling errors. So we're going to make a call to a helper method called getTransformConsumer. GetTransformConsumer is going to go look up in the transform map to see if there's a value, if there's a consumer based on the transformer name. Now, if all goes well, you passed in a valid name, the map is correctly initialized with the right strings, you should get back a consumer. If you don't, however, if you look up something that's not indeed in the map, then a null gets returned. That's what map does when you give it a key for which there's no entry in the map. So we don't want to have to deal with nulls. So what we're going to do is we're going to wrap that value, be it null or non-null, in something called an optional. And an optional is a clever little helper class in Java, as of Java 8, that is never null. It either has a value and it's present, or it doesn't have a value, in which case it's considered absent. And so you never have to worry about null pointer exceptions if you use null, and we'll show why. We use the ofNullable factory method, which will either create an optional that has a valid value, which would be the buffered, the consumer to the buffered image, or it's empty. And that's what gets returned. You can see getTransformConsumer returns an optional to a consumer to a buffered image. What we then do, and this is the part that's pretty cool, we're going to be able to do fluent interface style programming. We're not going to have an if-else check anywhere to see whether or not we got a null back, because we're never going to get a null back. We're either going to get back an optional with a value or an optional that's empty. If we get back an optional with a value, then the accept method is called on that. If we get an optional back that is empty, then this or else throw method will get called. And what or else throw does is it throws a transform exception saying that this transform name corresponds to an unsupported transform type, which is just an indication that the server has been programmed incorrectly or something has gone awry with the data that the client sent, and earlier checks did not catch that. So you can see we're either going to get the result, or the result being the transformed image, or we're going to get an exception thrown, in which case nothing will happen after this point. if all goes well, buffered image is then transformed using that consumer that was in the map, and then we create a new transformed image and send the results back to the client. So that's the server-side exception handling. And you can see it took place at several levels. We did some sanity checking in the controllers just to make sure that things were copacetic, and we threw the appropriate exception, which in this case is a response status exception if it was not copacetic. And then inside the main service, we did a check to see if we had a valid transform name. And in the transform service, we also do some sanity checking. And the long and the short of it is, by doing it this way, now we're in good shape, and we don't have to worry about swallowing errors and not reporting back to the client what has happened. Speaking of the client, now we're back over on the client side. And I'm going to just focus on the parts of the code that are called by your streams implementations, either sequential stream crawler or parallel stream crawler. Doesn't matter which one we're calling. At some point, if it's doing remote calls, the transform image remotely method is called, and it ends up calling this method in the remote data source file called apply transforms. So this is now on the client side. This is just good old Java code. So we take in the image, we take in the transform names, and a Boolean. And this is really cool. This is where we're actually going to make the call to the server using something called Retrofit and deal with errors that come back. And this is what it looks like. So we go ahead and we use this API field. The API field is basically the Retrofit proxy, if you will. And we say, hey, go ahead and create me something known as a call object that's going to represent the transform names passed in as a list and the image passed in as a multi-part body part and the parallel flag and so on. We're going to make an object. It's basically turning this thing into a command, if you will, a call command. And then we're going to use the execute method. Now, execute says, take this call, send it over to the server, and then get the response back. And what comes back from execute is a response object, which, as you can see, is a response to a list of transformed images. It doesn't give back a list of transformed images directly. It gives back a response to a list of transformed images. And the reason for that is that allows us to be able to check to see if things went awry or not. So if the response is successful, that means the server executed the code properly, hopefully, if we wrote our implementation correctly on the server side, but there were no errors detected. And in that case, we take the response, we get the body of the response, and that gets sent back as a list of transformed images. However, if we were not successful, then we have to deal with the error response. And so what we do here is we have this helper method we'll look at called convert error to exception, which takes the error body in the response. And here's what convert error to exception does. The first thing it does is it uses some retrofit adapters to essentially take the JSON, which is how the response body comes back, and it converts it into something called an error response status object. And then we go ahead and we use this converter to convert the error body into the error response status, and we'll see what that is in a second. And then what we do on the client, this is really cool, we create a new instance of a client exception called transform exception, passing in the error response status object. So let's go ahead and take a look at what that is. Here's the transform exception. Now this transform exception here is different from the one we looked at earlier. The one we looked at earlier was on the server side, and now we're on the client side. And on the server side, it was a Java exception. Transform exception was a Java exception that had been annotated with the response status annotation that would tell Spring to bundle up this thing into an error response body and send it back as the HTTP response. Now we're on the client side. We've received that response, that buffer of the bundle of JSON, and it's now in this thing called an error response status class. And you can see what comes back from the server, the timestamp when the error occurred, the status of the response, for example, 404 or 501 or whatever. We can control what that is. The error, the exception that occurred on the server, the reason the exception occurred, which is a little bit more descriptive explanation of why things went awry, and then the path of the original request. So it would be like, / apply transforms. And here is the constructor for transform exception. It takes this error response status object, which was converted from the JSON into this object, and we stash it away in a local variable. And then when someone wants to get the message contents of this exception, we go ahead and say, error response status, convert yourself to a string. And what that does is that takes this particular encapsulated value, and then it turns it into a string. It turns it into the string form of this, which looks like JSON, if you know what JSON looks like. And so it'll then go ahead and print that value out. So now, when an exception occurs, the client will be informed of this by having the transform exception thrown, and then the client code can handle this in whatever way it deems appropriate. So this hopefully gives you a much better understanding of how you can model error handling on the server side, throw exceptions, good old Java exceptions, have them automatically converted into an error response body in JSON format by the Spring adapter framework and annotations. How on the client side you can get the results back as this response, and then use the response to figure out if you succeeded or failed, and then convert the error body to a local client exception on failure with the reason why things failed.